Now coming to the relation, the term which I want to introduce, that is correlation. So what happens? First example I am taking, continuous versus continuous. In that we have height versus salary, that we already discussed. And in that, if I want to know, that is, what is the like relation between, what is the relation between these two variables, that is continuous and continuous. So for that we have to check the correlation. Correlation, it means if I want to, let's say here I have height here, or just opposite island, this is y, so the salary here and height here. So if you plot it, just imagine I am plotting it. So if you are getting like this, okay, so you can say now, okay, when height is increasing, your salary is also increasing. It might happen in some cases that your salary is here and height, you are getting like this. These are random points, random points, random points. Then you will say there is no a particular relationship between this, because you can say there are some values here. Or if I want to make it more clear, just bear with me. Yeah. So here, these are the points like this. If point is present, so you can say there is no clear relationship. If there is one more thing, like if your point is like this, so you can say with height and salary, with height being more, your salary is decreasing. So any of the relations might be there. And this you can see by just plotting it. Or you have, if you want, you can just not you cannot differentiate between these two, right? If you have the like this one graph, and you have something like this, so you cannot differentiate which is like which relationship is more. For that we have to quantify that, we have to give some number. For giving that number, we have this function, this, not, let's say this one statistical measure, which you have to which you can use to get that number, how much this height and salary is related. So for that, what do we call them? That is correlation. I want to find correlation between height and salary. As name itself suggests, that it will tell me the correlation between height and salary. All right. It is also called Pearson correlation. In that, how we calculate that? This R is will be a correlation coefficient. All right. This will be correlation coefficient. And Rxy means this will be X here we can take as explanatory variable. Y is response variable, or in this case we have this as a height and this as a salary. So how we calculate it? This is covariance of xy versus standard deviation of x and standard deviation of y. All right, standard deviation of x and standard deviation of y. Okay, so standard deviation, here we divide by standard deviation of x and standard deviation of y. So going to the covariance, how covariance is calculated. So for population, we calculate covariance as summation of each element x here minus x bar multiplied by yi minus y bar divided by n. N will be number of samples. Okay, number of samples here. And this covariance xy for sample, or you can say number of samples or number of observation, you can say in this case, because it will be confusing if I say for sample. For a population, the number of observation in that population, that will be get divided here. For sample here, and will be number of number of observation minus 1. And same thing will be followed. Each element will be minus by like you subtract each element with its mean, and then the second, this is explanatory, and then for response also you get the mean of it and you minus it and multiply into the summation and divide it by n minus 1. All right, and this will go here, and you divide the standard deviation x and standard deviation, and it will give you the correlation. Okay, you got that number, right? So for calculating it, it might be confusing here. I will give you by an example. I have given this. Let's say I have taken this example, salary versus height here. Sorry, height versus salary here. So in this, the example, for example, is if my height is 5.5, the salary will, annual salary is, let's say, 10 million. If height is 5.4, then salary is 12. 5.9, 26, and 40. So what is happening here? I have from the population, I just took some sample, And in that, like, four observation was there, just for explaining like how correlation is calculated. This is like very small sample just to show you the calculation of it, like what we will get here and what we are going to achieve, right? So for that I have this as a x, okay, and this as a y. This is my explanatory, this is my response. All right, so for x, how we calculate, the first step will be to calculate the mean x bar. So x bar is again pretty straightforward. You sum it up and divide it by number of observation and you get 5.7. Now next is you get the mean of response variable. For that you have 10, 12, 20, 40. You sum all observation, 4 observation, and divide it by number of observation, you get 20.5. Okay. Next is to calculate the standard deviation. For standard deviation, what you do, you calculate the variance, all right, and you square it up, get the square root of it. So and here I am using n minus 1, all right. This is n minus 1 because I am assuming this is sample, all right. I am taking sample, you and not population. That's why I'm doing n minus 1 here. So standard deviation value you will get as 0.29. In this case, when I get take the standard deviation of y, that is my response. So in that case, again same thing I'm following, like 10 minus mean. This is nothing but x minus x bar, or you can say y minus y bar in this case. Similarly, y minus y1 minus y bar, y2 minus y bar, and this is y3 minus y bar. All right, y4 minus y bar. There's nothing but just you don't have to be confused here. Just 10 minus 20.5. This is the value. 10 minus the mean value here. This is the mean value. 10 minus 20.5. Similarly, 12 minus 20.5. And then 20 minus 20.5. And similarly, 40 minus 20.5. Right, 20 minus 20.5. And what is it? Whatever the difference is, you square it up and divide it by n minus 1. And then you do the square root. You get the value of 13.7. Next is you have to calculate the covariance. All right, for covariance, what you do, you have that formula. If I go back and show you quickly, x1 minus x bar into y minus y1 minus y bar. That is what I am doing. X1 5.5 is 5.5 here, minus 5.7. So 5.7 I am doing here. This is what it is. And then 10 minus 20.5. 20.5. So these both will be multiplied. Then again, same thing will happen, same thing will happen, same thing, and this will be multiplied. And then after multiplying each, you sum, do the sum. All right. After doing the sum, you divide it by n minus 1 for the sample. I'm taking this as a sample. That will come out around. That will be around 3.46. This will be the value actually. This will be the value you will get. And then for correlation, if you remember what we do, for correlation, we have 30, 34 point, for correlation, what, how we calculate it, covariance of x and y, and then divided by a standard deviation of x into standard deviation of y. Just I have to stop this. Okay, now, yeah. So the formula is covariance divided by standard deviation of x into standard deviation of y. So here the same thing I'm doing, 3.46 we got as covariance of x and y, and then uh, just wait 1 second. Yeah. So here, where was I? Here, covariance. So the formula is covariance of x and y, covariance of x and comma y, and divided by standard deviation of x into standard deviation of y. So covariance of x and y, how much I have got? 3.46, and then I divided by 0.29 here, x value, and then this value, and then multiplied by 13.7. So finally you will get this number, 0.87. Now 0.87, right now just think about it, 0.87. The correlation basically ranges from 0 to 1. So more it is closer to 1, that means this relation between these two is very strong. And if the value is positive, that means if your explanatory variable is increasing, it means if your height is increasing, your salary will increase. All right, this is just an example I have taken. According to this four observation, it is showing me that it is coming out to be 0.87. That means if height is increasing, your salary will also increase. So if you see what I have curated for 5.4, I have just 5.5, it is 10. 5.4, it is going in this example, it is going less. But if you see general trend, 5.9, it is 26. In 6, it is 40. So if your height is increasing, your salary is increasing, and that is what it is shown by this number. That means it is closer to 1. That means the relation is high, it is positive, right? This is positive. That means your correlation is coming out to be like positive. All right, it will increase with the increment. Okay, all right. So you think about how negative will come here. So just see here, in this case negative might come when you have when you're calculating covariance, then covariance can be negative. All right, covariance can be negative. Okay, okay. So going to the next slide, I hope this is clear. I will tell you like how to identify whether it is strong. There is a bucket of it, just wait for that. In properties, I will explain you more which number, how much it actually explains. If your number is, if you're getting this number as 0.2, then whether it is strong or very weak, or in which bucket it comes, that I will explain later on. So don't worry about that. Now, next is continuous versus categorical. I was talking about categorical ordinal here. So height versus shoe size. So in that case, if you think this is shoe size, it is not like continuous. So you cannot apply Pearson correlation, but we have another uh, correlation statistical statistical method that you can use, that is Spearman rank correlation. In that the formula is 1 minus 6. This formula I will explain by next example. So how you calculate it, so let's go to the example here. So it's very simple. What I'm doing, let's say now I have height here as one variable, and this is shoe size. So this is my actually this is my sample size. I take person, 4% example I have taken, and in that case, one person height is 6 feet, another person height is 5.2 and 5.7 and 5.4. The shoe size is 10, 5, 6, 4. It is pretty simple, right? It's pretty explanatory here. So here, this is independent variable, or you can say explanatory variable. This is E, and shoe size is our response variable, right? This is my response variable or dependent variable, you can say. Now, how we can check the calculate the Spearman rank coefficient. So for that, the first step would be to calculate the rank of height. Rank, it means you have to give the rank, like everything will be same, everything will be the same. Just think about, you are adding a new column here. In that, what you are writing, you are giving this 5.2, that is the lowest, so you will give the first rank here. All right, this is the first rank. Now similarly, the next number is 5.4, that is the next highest. So the 6 is the highest and this is the lowest, and this, that is the next number. 5.5, after 5.2, 5.4 will come, and that is second. Then you have 5.7, that is third, and the highest is 6, that will come out to be 4. So similar thing will happen, that is rank 1, that rank I have created. That rank is basically in ascending order. The first will be the lowest and fourth will be the highest. Similar thing will come under shoe size here. So here the similar, if you think about ascending manner, ascending, you have first I'm giving as the lowest, that is 4 is the being the lowest, then 5 being the second, and then 6, 3, and then 4 here, that is the highest. All right, now what you do, you just take the difference of rank 1 and rank 2. All right, it doesn't matter if you do R2 minus R1 or R1 minus R2, because the finally you have to do the square. So if you do R2 minus R1, it will be, let's say, positive. If you are doing R1 minus R2, it will be negative. But in any case, d square will be the positive one, so don't worry about that. So you can do R1 minus R2, and for this 4 minus 4 is coming to 0. Next is 1 minus minus 2, that is minus 1, 0 and 1, that is simple here. And then I'm doing square of each and every number, that will come out to be 0, 1, 0, 1, right? Now next, what I do, the formula, if I go now, it will be clear. This t square is that difference, right? This d square is the difference. So what I'll do, I will do the sum of d square. So the sum of d square, that will be 2. All right, this value here, this whole value will come out as 2. Now it is like straightforward. Now if I want to calculate the correlation here, so in that case what I have to do, 1 minus 6, 6 here, 6 multiplied by 2, this value, 6 multiplied by 2, and then n into n square minus 1. So what is this n here? N is number of samples, or number of observation, better you can say number of observations. Okay, all right, observation. So here we have how much observation? 4 observation here. All right, so all number put in here, so we will get 1 minus 6 to the 12, and then 4 into 4 square, that will be 16, minus 1, that will come out to be 15, and if you calculate this, that will come out as 0.8. Again, that is strong. All right, so both of the time I'm telling, okay, that was 0.87 and this is 0.8, and in both cases I'm saying this both are strong. But then this I have written very strong and this I have written strong. So how to know which is very strong and strong, that will come in the next slide. Oh, I hope this Spearman rank calculation is clear. It is very simple. First you have to for x and y, for both you have to do the ranking. You have to give the given ranking in ascending order. One will be the lowest value number, and the last one will be the highest. Similarly for y also, and then you have to do the difference and you calculate the d square, and you do the summation of d square, and then you put in this formula. Alright. So now this both calculation, I hope it is clear. Is the Pearson correlation and the Spearman rank coefficient. This Spearman rank correlation, right? So now next I want to say this is pretty thumb rule. When you are getting value between 0 to zero point 0.2, then that is very weak. That means both your response variable is not being explained by explanatory variable. If that is between 0 0.2 to 0 0.4, then that is not very weak, but still weak. It will not be explained much by that explanatory variable. Then moderate, and then it goes here, and then very strong. So earlier in Pearson correlation, the first case where I was talking about height versus salary, in that case I was getting 0.87, right? That's why I have written very strong. And in the second case where I was talking about height versus shoe size, so in that case it was coming out to be 0.8. That's why I told it as strong. Okay, so now a few properties which I want to talk about, that is this is R is nothing but the correlation coefficient, the values which we were getting. So it might range between -1 to 1. All right, it might range between -1 to 1, and for positive association it will go from R. If R is greater than 0, the value is greater than 0, it means the association is positive. It means like if one variable is increasing, the other another variable will also increase. The negative association is if one variable is decreasing, that means the value, if R value is negative, it means one variable, if your explanatory variable is increasing, then your response variable will decrease. It means, let's say if you have something like cold versus ice cream, right? Or you can say winter versus ice cream. It will make more sense than winter versus ice cream. So what I'm talking about, if you're if your uh, weather is cold, then your what will be the sale of ice cream. So it might happen like if your, or just I'll write one thing, that will be temperature, and it will explain. Yeah. So temperature versus ice cream. So temperature basically weather I am talking about. All right. So weather I am talking about. So if your temperature is high, then your ice cream, no, I think it will, yeah, if your temperature is high, then your ice cream sale will increase, right? And if it is low, then it will also the sale will decrease. So it is showing me the positive correlation. All right. So if I want to give you negative correlation. Example, let us say when temperature, the sale of jacket now, all right, sale of jacket. So in this case, if your temperature is high, if I talk about temperature versus jacket sale. So if your temperature is high, your jacket sale will be low. If your temperature is low, your jacket sale will be high. All right. So in this case, this will have a negative association, and R value will be negative. And if you have no relationship, then R will be, R is equal to 0. In that case, that is pretty random. All right. That will come as random. It means that it doesn't matter whether one increases or decreases. The other variable is independent of that. And correlation is unit free. It means it doesn't have to be the same unit. If you can see here shoe size unit is different and height unit is in feet. In first case also, the salary unit is in million, and height is in feet. So it doesn't matter what is the unit of x and y, it is unit free. And the correlation between x and y is equal to the correlation between y and x. It doesn't matter whether you are calculating correlation between x and y or y and x, it will give the same value. All right, it depends upon you which you are keeping as explanatory or which you are keeping as response variable. Either if you switch this, then also you get the same correlation value. Right now I will give you the graphical relationship. Here you can see when I am getting this 0.05, that means it is very weak, right? It's very weak. So you can say there is no, if you draw a line here, all right, if you draw a line here, if you have this negative, so it will go a little down, but there is very little relationship here, and there is like it's almost random. So if you see, this is a pretty linear line. If it is going, if one value is increasing, this value will also increase, and this value is coming out to 0.96. It means like it is positively correlated, that one is increasing, another will also increase, and the value is very high. The next is like weak positive correlation. So 0.71, it is not that weak. If you say, if I check, it is coming out in strong, it is in strong only, but it is coming out to be 0.71. You can say it is not weak, actually it's just written here. Next is none or low positive correlation coefficient, that is coming out to be 0.04. That means no relationship here. In this case, strong negative, you can see here, and weak negative correlation. This you can say as this will not be actually zero point 0.7. I think this will be around 4.1.41. Then you can say it is around weak or moderate. Okay. In this case, this is minus 0.45, so it is negative, and it will also come under moderate, or you can say mostly the weak. So general thing which you have to follow, it is around this only. If you 0.2 to 0.4, then you say weak. If it is around 0.4 to 0.6, then it is moderate.